Welcome to ThirdEye Labs, where we make the unseen seen. Today, trigonometry and the unit circle. Here is the whole machine. One circle, radius exactly 1, centered at 0. One spoke that can point anywhere, and one number that says where it points. The angle theta, that is all trigonometry is. Questions about this picture. No triangles required yet. Picture a clock with a single hand, exactly 1 unit long. Freeze it at any moment. The angle of that hand is the only thing that matters. Everything in this episode is just questions about where that hand points. Point the spoke at 60 degrees and look at its shadows. The shadow on the horizontal axis is the cosine. The shadow on the vertical axis is the sine. At 60 degrees, the cosine is exactly 0.5, and the sine is about 0.866. Cosine answers how far across. Sine answers how far up. They are coordinates, not ratios. Now shine a lamp from above. The hand casts a shadow on the floor. That shadow is the cosine. Shine a lamp from the side, and the shadow on the wall is the sine. 2 lamps, 2 shadows, 1 spinning hand. Before we spin, 4 snapshots worth knowing by heart. Read straight off the circle. At 0 degrees, the point sits at 1, 0. At 90, 0, 1. At 180, -1, 0. At 270, 0, -1. No formulas, just locations. And at 45 degrees, the diagonal, both shadows are equal, about 0.71 each. Check it. 0.71 squared twice is 1. Now let it spin and unroll time to the right. The up-down shadow draws the sine wave. The left-right shadow at the very same instant draws the cosine wave. Same point, same spin, 2 recordings of it. Notice the cosine is just the sine arriving a quarter turn early. Every wave you will ever meet, sound, light, alternating current, is built from exactly this. Stick a dot of wet paint on the rim of a bicycle wheel. Spin the wheel while pulling a strip of paper past it sideways. The paint bobs up and down, and on the moving paper it draws a perfect wave. That wave is the sine. Why do mathematicians measure angles in radians and not in 360 degrees? Because of the radius. Take the radius, bend it along the rim, and walk. 1 radius of arc is 1 radian. Walk 1, 2, 3, 4, 5, 6 radius lengths, and you are almost home, with 0.28 of a radius left over. A full lap is 2 pi radii. Radians make the circle measure itself, and that is why every formula in calculus and in machine learning speaks radians. Imagine a circular pond. You walk around the edge, and you measure your walk in lengths of the pond's radius. 1 radius of walking is 1 radian. The whole lap is about 6.28 radius lengths. That number is 2 pi. Here is the most famous identity in trigonometry, and it is free. The spoke has length 1. Its shadows are the legs of a right triangle, so Pythagoras says the legs squared sum to the hypotenuse squared, which is 1. Check it with real numbers. Point the spoke so the shadows are 0.6 across and 0.8 up. 0.64 plus 0.36 is exactly 1. Sine squared plus cosine squared equals 1 is not a rule to memorize. It is the radius being the radius. Spin past a full turn and nothing new happens. The wave repeats exactly every 2 pi. Add 2 pi to any angle and the sign does not change. That makes sine and cosine the native language of anything that repeats. Heartbeats, sound, seasons, alternating current, orbits. If it cycles, trigonometry describes it. Ride a Ferris wheel and plot your height over time. Up, over the top, down, around, and back to the start. The graph is a sine wave, and every lap repeats it exactly. Periodicity is just the wheel coming back around. Every wave you will ever build has exactly 2 knobs. Multiply the angle and the point spins faster. Sine of 2 theta wiggles twice as often. That knob is frequency, and in sound it is pitch. Add to the angle and the whole wave slides sideways. That knob is phase, and sliding by a quarter turn turns sine into cosine exactly. Spin rate and head start. Frequency and phase. In the lab, we will turn both knobs in NumPy and build waves to order. Why does a machine learning channel care about a spinning point? 3 reasons. Rotating an image or a vector is pure cosine and sine. The Fourier transform, which we use to draw with circles, builds every signal out of these waves. And transformers, the models behind modern AI, tell each word where it sits in a sentence using sine and cosine waves of different frequencies. This pattern is a positional encoding. Every column is one position, every row is one wave, and together the stripes give every position a unique barcode. Now the misconception. School says trigonometry is about triangles, and that is how most people lose it. Here is the reframe. The triangle is real, but it is a single frozen frame. Let the angle move and the triangle morphs, frame after frame, while the circle plays the whole movie. Triangles are snapshots of circular motion. Learn the circle, and every triangle fact falls out for free. A quick story. Indian astronomers around the 5th century called the half-chord of a circle jaya, the bowstring. Arabic translators wrote it as jiba, but Arabic omits vowels, so later readers misread it as jabe, which means a bay or a fold. Latin translators then faithfully translated the wrong word as sinus, a bay. So the name sine is literally a 1,000-year-old translation mistake. The mathematics underneath never noticed. In one breath, sine and cosine are the two shadows of one spinning point. Radians measure the walk along the rim in radius lengths. Sine squared plus cosine squared equals 1 because the radius is 1. And anything in the universe that repeats speaks this language. One last thought before you go. One spinning point draws one wave. So what could 1,000 spinning points, chain tip to tail, draw? We have already answered that on this channel. They can draw anything. A face, a song, any signal in the world. That is the Fourier transform, and it is where this little circle is headed. Next time, the arrow that is secretly a list of numbers, and why every piece of data is a direction in space. Thanks for watching and keep exploring. Next time, vectors and coordinates. Please like and subscribe ThirdEye Labs if you enjoyed this video and let me know in the comments.